Today I'll be taking you through this physics problem of motion, which came from the external examination body of WAEC from the 1997. So we have an object of mass 0.4 kg attached to the end of a string is whirled around in a horizontal circle of radius 2 meters with a constant speed of 8 meters per second. Calculate the angular velocity of the object. Well, I'll do a little bit of explanation and then I will solve this problem. So, if I had a particle suspended to a string and I whirled it round a circular path, I think the radius is big, alright? And I whirled it down a circular path. I think I'll have something that looks like this. Now, the truth is that the speed through which it travels the circumference of the circle is called the angular velocity. We represent it with the figure omega. And always, whenever we let go of this particular particle from the center, it always has this propelling property that makes it travel away from the circular path in a straight line. And that's what we call the linear velocity, or you could say the speed. Now, that being said, the relationship between the angular velocity and the linear velocity, or you say the speed, is given by W equal to V divided by R. So this is the formula. You should always know that if you're familiar with motion. And we have 8, which happens to be the constant speed, divided by 2, leaving you with 4 rads per second. There's an explanation for this in different ways, where we have a centripetal force. The force responsible for this particle x traveling in a circular path is given by mv squared over r, and also can be represented as mw squared r. So when m cancels out m and we divide through by r, you find that this gets to cancel this, and okay, we have this times is giving you r squared over v squared. This is v. It's all messy, I know. All equal to omega squared. So square rooting both sides eliminates this, and then we have the omega to be v over r. I hope that makes sense to you.